So let's draw a little picture of what's going on in this problem. We have a 30-volt EMF source that's connected to a capacitor. It's a parallel plate capacitor. And initially it's got a 540 microfarad capacitance. And what we do is we let this thing completely charge up, and it'll contain some energy. Then after that's done, we insert in the region here a dielectric constant, or dielectric material. It completely fills it. It's got a dielectric constant, K is equal to 14. We let the capacitor charge up to a new value. It has a new energy. And the question is, what's the difference in energy stored between the two situations? All right, well, potential energy in a capacitor can be written in many different ways. In this case, however, the voltage across the capacitor is always constant. We've always left the 30-volt EMF source hooked up. So the easiest expression to use is the fact that the potential energy stored is equal to 1/2 times the capacitance times V squared. So let's go ahead and calculate the potential energy stored in the initial case, U sub I. Well, the capacitance in that case is specified, 540 coulombs per volt. And the voltage in this case is 30 volts. And so all we have to do is a little simple bit of algebra to calculate that the initial potential energy is 0.243 coulomb volts. Okay, and a volt is just a joule per coulomb. It's one of the ways to write volts. And so it's 0.243 joules. So that's the initial energy stored. What's the energy after the dielectric is inserted? Well, we insert the dielectric and let it sit to charge up. Once it's completely charged up, we'll have a new capacitance. C naught we can have be the original capacitance. That's the 514 microfarads that the parallel plate capacitor was before the dielectric was inserted. And the action of a dielectric is to increase the value of the capacitance by this factor K. And so what that means now is that we've got a new value for the energy stored. I can write this coulombs per volt, still 30 volts squared. And so what we need to do is calculate this number. And when I put the numbers together, I find that this is 3.402 joules. Okay, and then this asks for the difference. So just U sub F minus U sub I. That's 3.402 joules minus 0.243 joules. Three significant figures then. The energy difference is 3.16 joules. Okay. So the dielectric dielectric material, by increasing the value of the capacitance, allowed more energy to be stored in the capacitor.